Welcome everybody to the second installment of the Studio Geo webinar. So last week we basically covered how we go about just setting up our models from the get-go. So, creating the drill holes, selecting what we want to model up and creating these nice combined models. So this week we're going to go through shapeshifting. So basically how we're going to edit and shape our wireframes using a whole range of tools that we have in Studio Geo to do this. So this is me. Hello, I'm Joe, geology consultant here at Datamine Perth, and I'm the technical lead for Studio Geo. So I deal with a lot of the rollouts, troubleshooting questions to do with Studio Geo. All right, so just having a look a little bit at where Studio Geo sits in our mining value chain, which is our kind of suite of softwares. So Studio Geo obviously sits smack bang in the middle of geology. So that sits with our other products like Studio RM, Studio Mapper, Supervisor, etc., etc. So we've also got all of our other software solutions. Now, one of the reasons why Studio Geo was created was because we had a little gap in our software and we liked to try and integrate everything into the one platform. So this just means that we're not going to have any issues in terms of converting files from one software to another, dragging things out, pulling things back in, just to do, your work. So all this is all integrated. We share the same file formats. It's very easy to import, export into other Datamine softwares. So there we go, Geology, right in the middle of your kind of workflow, typically on site. So just another little look at some other softwares that we have. We also have a whole bunch of softwares that kind of lie outside of our daily production stuff. So this is our production softwares, lab softwares, and sustainability softwares. So as you can see, Datamine has a very wide range of software solutions for basically everything that you'd ever want to cover. Okay, so what are we going to cover in this section? So we're going to cover where our implicit modeling generation tools are located, so where to find them in the 3D screen. We're going to then look at what tools that we have at our disposal, and this will include a couple of kind of demos into how some of the tools work. We'll look at the differences between the surface, vein, and categorical options. So these are our three main types of wireframes that we can create. They all have very slightly different tools for each of them. So we'll probably mainly focus on the vein and categorical. The surface shares almost all the same tools as the vein. So if you know how to use the vein, you'll also know how to use the surface. So we'll have a look at seeing how the options will change the shape of our wireframe, basically to get the wireframe in the exact shape that we want. And we might also touch on editing our wireframes using the interval selection tools. So I kind of touched on this last week. We've got some very easy to use interval selection tools. And these can be basically used in unison with our other tools to get our shapes looking exactly how we want them to. All right, so it's time for the live demo now. So I've got Studio Geo up here. I've just got a couple of shapes I've already loaded in. So we can see here, we've got a couple of nice vein surfaces. Within this specific model, I've also got a contact surface, which is basically just a contact plane between two units. I've also got some categorical wireframes in here as well. So this is a categorical wireframe. This is actually brand new. So the new version of Studio Geo that's coming out in a couple of days is introducing these categorical wireframes. And these categorical wireframes allow us to do a lot more in terms of what we want to model up. So we'll have a little look at these as well. They have quite different options to our regular kind of vein and contact surface tools. So first thing first, we've got our wireframes here. We've generated our wireframes. This is what they look like. So we might be, pretty happy with them. We've got our whole set here. But there are some things that we might want to change. Maybe it's the general shape of the wireframe. Maybe we've got little issues like, say, a little hole in our wireframe. So what can we do to actually change these and, improve our wireframe to make it more realistic? So for all of our implicit tools, we have right here in our geology model here, we've got a little cog. So this cog says settings. This allows us to configure all the settings for this object. So if I click on this little cog, it's going to pop out the vein surface generation options that we have here. Now, the first thing you'll notice is when we open up this menu, all of these little red dots will appear on this side, and we'll also get a whole bunch of little green dots on this side. So in the case of a vein surface, like we're looking at here, these are the hanging wall and the footwall points on either side of our wireframe. So just up here, we can see it's possible to just change what we want to look at. So currently we're looking at shear B. We could use this drop down to select a different wireframe if we wanted to, or even a different column. So if we're modeling up a couple of different things at the same time, say we've got our geology and we've got our loads, we can kind of flick between them here. Typically, just using these cogs is pretty easy because you can see exactly what you're going to be editing. So first up here, we'll just jump down to here. So just before we start opening up all of our individual menus. So one thing that's quite important to know is this best fit plane. So the best fit plane is basically a trend surface that links all of our points together. So typically, we're going to leave this on auto. So when we leave this on auto, our best fit plane is basically automatically generated from our sample points. So these are our sample points. It goes awesome. I want to create a surface right in the middle that hits as many of these points as possible. So it calculates that for us and then outputs us a trend surface. So you can see the trend surface independently here if we were to turn on. I'll get down to these options a little bit later. Now, the other option we have is if you have a certain orientation that you know your unit's trending in. Now, this is more important when you're only looking at a little subset of your data. So if you have a very large wireframe, you only want to focus in on one part, the trend of the whole wireframe might actually be different to the single part that you're using. So what we can do is we can actually put a custom best fit plane in. So in here, what we can do is we can basically enter in our ASI and dip, and that will help guide the wireframe. So typically, we won't see much in terms of a change in shape of the best fit plane. So what it will do is at the ends of our wireframe, where we're lacking a little bit of data, it will actually orientate these slightly differently based on our best fit plane. The other thing the best fit plane does is for some of the tools in here, so especially something like the boundary tool, we're going to have the ability to create a custom boundary. That boundary actually will boolean on that best fit plane. So that's just something to keep in mind. If you change the best fit plane quite a lot, sometimes the boundary might look a little bit out. We'll have a little look at that when we get to it. For most cases, you probably just want it on auto, especially in this case here, where I'm looking at the entire wireframe and it's fairly uniform. There's no major kinks, nothing's going too far out of place. All right, so when we're looking at the vein surface menu, all of our options, you'll notice that there is a whole bunch of little boxes here. Now, these act as drop downs. So if I click on my edit samples, there you go. So this will open each little toolbox individually. So as you can see here, we have 5 different toolboxes along with all of our other various tools. So having a look at our first toolbox, this is the edit samples toolbox. So each of these red and green dots here, they represent a sample. So we've gone down, we've done the logging, and we've decided where all of our intervals are. So what we can do from here is sometimes when we generate our implicit wireframes, we might have a couple of points that are out of place that are causing issues. Now, this can be from a whole range of things. Maybe it's incorrect logging, so you've logged the wrong rock type. Maybe you mistook, one rock type for a different rock type, and it's causing a bit of a bulge in your wireframe. So what we can do here is we can actually go and turn on and off individual hang wall and footwall points. So for example, there's a little tiny hole all the way down the bottom of this wireframe. I think it's about here. There we go. So we've got this little tiny hole here. Now this hole is caused from basically there's a little tiny intrusive unit that kind of comes through and cuts our main unit in half. Now with the vein tool, so the wireframe that we're looking at is a vein wireframe. It doesn't like it when the samples are not continuous. It can't properly generate the hang wall and footwall. So what I can do is right here, I know, hey, I've got one sample that's 50 centimeters wide. You know, I'm more than happy to just join these units together. So I'm going to tick on this off button. Now you'll see here, there's a little red dot. So that's my sample. I'm just going to highlight it. And as you can see, that little red dot has now become hollow. So that just means that that sample has been turned off. The good thing about it being hollow is if you do need to turn it back on, it's very easy to see where your samples are. The other thing that we could do is we could just simply turn off the wireframe. So now we can see down here, this one's hollow. We can also see a footwall point here, which is also probably causing our issues. So what I might do is I might turn that one off as well. So now what it's doing is it's basically just joining all this together as one large sample. Now, also in this box, if we had issues like this, just it's quite common to have little intrusive units coming through at various points. We do have an option to basically ignore gaps. So what this means is where we have a gap in our sample interval, so in this case, just this little one here, ignore gaps will basically look at the first and the last sample, and that's it. It won't take into account any samples in the middle. So I could turn that on. In my case, I've just gone and turned them off. So what I can do is if I turn on my wireframe again, we'll see there's a little hole there. What I'm going to do is when we change one of our options in the kind of options box that we have here, what I can do is I can just update my vein. So this just means that I don't have to update my model every single time that I want to make a small change. In this case, I've just made one small change here. I've updated it and then, hello, it's all gone. So now we've got a much smoother wireframe surface there, probably a little bit more realistic. We can use this tool for everything as well. So in some cases, say up here, we might have a bit of a, bulge out in our wireframe. Again, this could be true to real life, or maybe it was some, incorrect data getting in. Once again, I can just turn off the, hang wall point. So there we go, it's gone hollow. Now, if I update my vein, we'll see that that little bump there will disappear. So we don't need to turn off both of them. We can just turn off one at a time. Cool, there we go. So now it's ignoring that sample point and only using the footwall sample point. So you can see that right there. Now, the other option that we do have in this menu is our swap contacts. So sometimes, Datamine's trying to assume which way our samples are going. Because it relies on a hang wall and a footwall point, it kind of needs to have these set in stone. So sometimes, especially when you're doing kind of drilling from different orientations, so in a bit of a cross like that, sometimes it will get the sample points mixed up. It's not exactly sure which one the hang wall and footwall points are. So we have this button here, which will basically just swap our hang wall and footwall points. So this one's very easy to use. You simply just highlight your points and it will change it from hang wall to footwall. So let's see if I can. So in this case, maybe just do one down here. Got a hang wall point there. It's changed to a footwall point. So that's really all it does. It's not a complicated tool. Finally, in this box, we have some snapping options. So by default, this has got to do with what happens when we either start or finish our interval at the start or the end of the drill hole. So what snap does is if we finish our sample at the bottom of our drill hole, snap will assume that that last sample is it, And then from there onwards, it's another unit entirely. So Snap will give you kind of like the cleanest wireframe to the drill holes. However, we can also do pass above and pass below. So what this is doing is it's telling Datamine's software that maybe the sample does continue downhole. We just didn't get samples for it. So we'll basically just create a bit more wireframe down the bottom end, or with the pass above at the top end. So if you're working underground, you've got the option here. We can also just completely ignore. So that just means that it won't even look at the sample. It's basically like disabling it in here. So that's all the options we have in our edit samples. Fairly basic, but very useful for kind of coming in and helping to kind of smooth out and change a wireframe. Especially useful because when you have a lot of drill data, there's always stuff that has gone wrong, during the logging process. So it can be quite useful to turn it on and off. So next up, we might look at our intrusion up here, and we'll have a look at additional points. So once again, I'm just clicking on my cog button. So the additional points basically allows us to add any extra samples that we might have. So typically, if we were, working underground, we might have, found, some samples in the wall that we want to map up and that we want to bring in to help shape our wireframe. So what we can do is using this tick box, there is a use additional points menu up here. And what I might do is I might just add a couple of additional points up on this end of my wireframe. See if I can, there we go. All right. So what I'm going to do is I'm just going to add a couple of additional points here, just so you can see how it works. Now, obviously, this would be more used, pit underground mapping, if the surveys have gotten any data that you want to drag in. Can also be used for stuff like your, face mapping. So if you do have, robust face data, what we can do is we can actually add it in as additional points. So in this case, because it's a vein surface, what I'm doing is I'm adding both hang wall and footwall points just to this one little area of the wireframe. So what these are going to do is they're basically just going to act as an anchor for our wireframe. They're going to pull our wireframe towards it and kind of snap it in place around there. So there we go. I've just added a couple of points here. They're very basic. So what I'm going to do now is I'm going to update my vein. I've got my additional points turned on. So we do have a couple of options here. If you have strings already, so the survey has given you strings that he's gone underground, we can just click on a string and add all points as a hang wall and footwall. We also have trend points. So this will slightly change the trend of the wireframe in certain areas. So as you can see here, it is a very basic example, but before it was just pulling it straight down. Now it's gone, oh, I've found some points. I'm going to pull my wireframe up so I can encompass all of them. And same goes for the footwall points beneath it. So we've got our green points here. If you're not happy with it, it's very easy to simply turn it off and update it again. So after this, we'll have a little look at the boundary. So close that box, open up the boundary. I'll just turn off those additional points. There we go. So those additional points are saved as basically a string file. So you can drag and drop them in. You can also just transfer them between various projects. So within our boundary, we've got two main options here. We have our auto boundary. This uses what we call an alpha shape. So it's basically like a search radius. And we have an extension distance. Now the extension distance is how far past our last point of data do we create our wireframe. So if I was unhappy and I didn't want to assume my wireframe continued on for 50 meters, I could drop that down to say 20. Our segment length is how far does it look between points to create the wireframe. So in this case, it's on 50 meters. So you can imagine basically a circle around each point that's 50 meters in diameter or in radius. Once it hits another circle, it's going to create the wireframe in that area. So just for example, I might just drop that down to 20 so you can have a see what it does. Awesome. So it just shrinks it down basically. Now we also have a custom boundary. So the custom boundary is where we can physically go and select our own boundary. So just get this in the right orientation so you can see what it does. So I'm just going to align my section to my wireframe. So this is where I was saying the best fit plane is used. So what I'm going to do is I'm just going to click on this button. It just allows me to digitize a new perimeter for my wireframe. So I'm just going to draw a nice little, it's going to be fairly basic, just all the way around. So maybe, for example, if I plan to drill, down in this area, I can actually extend my wireframe a bit further than the auto boundary. So there's my boundary. I'm just going to update my vein now. And when I update it, it's just going to fill out all the way to the edge of the boundary. So it's a very easy tool to use. It's pretty useful as well for defining the edges that you want. So I'm just going to leave mine on alpha shape for now. That's fine. Now I'll get to faults with the other wireframe. Just touch on surface controls while we're here. So surface controls are kind of like our basic options in terms of how thick do we want the wireframe? How do we want to deal with pinchouts? What do I want my boundary thickness to be? So first of all, we've got the minimum thickness. By default, it's set to 5 centimeters. You can make it bigger if you want, or you can just have it on 0, just pinch out to nothing. So here, if we do have a pinch out area, this will basically allow us to expand it to a minimum thickness, so like 30 centimeters or something. Or once it gets to a minimum thickness, 30 centimeters, it will actually just remove the wireframe in that area. So it just stops you having these very, very thin tails of wireframe appearing, in pinch out zones. We have 2 boxes here, maximum thickness. This just caps how thick the wireframe can be. So if, Geo detects points kind of slowly getting further and further apart, it'll actually cap that maximum thickness. If your samples are physically thicker than 20 or 30 meters, it will go on the samples. So the samples are the number one point of truth, and it will always follow the samples. It's just everywhere else in the wireframe. Boundary thickness will just control the boundary. So there we go. If I wanted to kind of trim this down to, say, a uniform 3 or 2 meters, that's where we can use this option. We also have a resolution here. So this is just how many triangles are used to generate our wireframe. And we have a pinch out option. So this is just how we deal with pinch outs. So if we have a drill hole and it doesn't have any sample data in it, the 2 options that we have are basically ignore the drill hole. So this means that, the search radiuses will still apply. And if, the wireframe connects with another point, it will simply create the wireframe over there. If I turn on pinch out, it will physically cut a hole in the wireframe where it does not detect a sample. So sometimes this is good, or sometimes this is bad. You end up with all these little cookie cutter shapes all over the place. So those are our surface controls. And then we have our generation options. These are basically extra objects that we can get out. So trend surface, boundary, or contact points. So I'll just close that. I will show you while we're here. Might go back to shear B. So I will show you basically our fault system. So we have 2 separate fault systems. We do have our, a fault block system, which is a model-wide fault system. However, we also have the ability to do single faults on single objects. So in this case, I'm going to select a fault, shear B fault. There we go. Now, what this is doing is it's going to use a fault object that I created before. There's that one there. So I just got 2 faults in here. And it's basically going to cut up my wireframe using these faults. So got that. Just turn off that boundary so we can see what we're looking at. Cool. So it's going to use these two faults basically to just cut up our wireframe. Now, because this wireframe is quite uniform, you're not going to see a massive difference. Obviously, if you had a major fault running through your data set, it will create quite a lot of offset. So what we'll see is we'll see a little bit of offset just near where the faults are. Now, this is just calculating it automatically. If we wanted to do a manual offset, so if you know your fault, offsets a unit 5 meters, what we can do is we can use a combination of the faults tool and then also the additional points tool. So there we go. Turn off this. So hopefully you can see there's not going to be much displacement, but especially down near the end where there's less drill data, you can see here quite clearly we'll cut through here. Up towards here, there isn't so much, and then maybe at the top there'll be a little bit more. So on this side, we can see kind of cut this section here and that section there. So the faults are very easy to use. I might do another webinar on how to create our faults as well. That'll probably be sometime next year. So we've gone through all the options here in our vein surface. Now, as I was saying earlier, we do have options as well for our contact surfaces, which is this toolbox. So each of our different object types have a slightly different set of tools. This one uses almost all the same tools as our vein options. So you don't really have to be too worried about, having to learn a whole new set of tools. Probably the only difference here is just our age relation. So, which point is younger and which point is older. Using this will create our contact points in here that it uses to generate the surface. Everything else works in the very same way, so we probably don't need to spend too much time on it. So finally, we've had a look at our vein tool. Now we also have our categorical tools. So this is what our categorical wireframe looks like. The difference between the vein and categorical is the categorical actually uses ellipses to create our wireframe. So that's why it might look a little bit bubbly. The good thing is we can do a lot more with our categorical. Stuff like bifurcation and folds are a lot easier using this tool. So once again, just clicking on my cog to open up my options, and we'll have a quick look at this before question time. I mean, it's already 11:30 here. So in here, you'll notice that the options do look quite different. Now, some of them will do basically the same things as what we've seen in the vein. So say, for example, additional points or, surface generation controls. These will do similar things. Now, probably the biggest difference is that we have a trends option up here. So like I was saying, with the categorical surfaces, we're actually using ellipses to generate our surface. So this allows us a bit more control in terms of, how far do we want our wireframe to generate, on what trend are we generating it exactly. So by default, similar to the vein tool, it's going to go default from holes. So it's going to look at your samples and it's going to go, I'm going to generate the best fitting ellipse for this data, and then I'm going to run it. However, we also have a custom tool here, which allows us to create our own ellipses and put these in. So very good for places, especially say folding or a fold hinge, where our trend surface actually does loop back on itself and come back around. So what we can do is we can actually create a number of ellipses at different points in our wireframe, and that will help guide the process. So I won't go through creating ellipses just because we need to get the measurements correct. Otherwise, it looks a bit funny. However, the last thing we can do here is we can actually view our ellipse grid, which is just using that view button. All this is going to do is just going to create some ellipses for us so we can see exactly where our trend lies. So there we go. So you can see there, it's fairly accurate to our wireframe. So there we go, I can line it up there. So that one's pretty well lined up. This is what it's using to basically generate the direction of our wireframe. So I'm going to turn that off. Awesome. So just back in here, so that's the trends option we have. We have a snap to contacts option. So the way that the contact snapping in categorical works a little bit different. So categorical will have a little bit of leeway in terms of how far it allows itself to snap. So if we do not want it to snap very far, so if we want to be exactly on our sample contacts, we can change this to low. So this will snap it very close to it. If we don't mind and we want to give it a little bit more leeway in the shape it generates, we can change this to high. So this allows a bit more variation. It will help in kind of connecting these ellipses together. We've also got the option to do fixed. So this is a fixed distance of snapping. So in this case, it'd be 30 meters, which is pretty high. Just beware, if you set this very low, it will take quite a while to actually generate the shapes. Maximum snap distance is just how far out from your contact point do you want your triangles to start orientating in that given direction. So if you can imagine pushing your finger into like a balloon and the surface deforming towards where your finger is, how far out from that point does it start turning in is basically our snap distance. We also have the pick contacts button here. So this works the same way. If we don't want to use a certain contact, so say that one, we can simply pick our contacts using this. And then I'm going to turn off my contact. So that won't generate that little bit there. It'll be kind of independent. Surface generation controls, again, these work in a fairly similar way. We do have a couple of other options here. It's good to read about these because these are a little bit more complicated. Subdivide can basically be left on auto. This is basically subdividing our samples into subsamples, and then it creates our wireframe and our contacts based on these subsamples. So we can actually subdivide it basically as much as we like. Resolution-wise, again, this is just how many triangles you use. Now, because the categorical surfaces are a bit more computer intensive, if you set this to very high, it will take quite a while to generate the shapes. So you'd only use this for your final pass. Most of your kind of day-to-day stuff can be done on very low. And then there's a couple of other options here. Percentage extra is just, how far do you want the wireframe to expand? All right. And then finally, we also have additional points. So additional points works in the exact same way. In this case, I think I've got categorical additional points. There we go. So what this will do is it basically I've got some points just down here. These are just little strings. So for example, this one here is filling in that hole. So what I could do is I can update the surface and that will kind of patch that hole for me. So while this is running, we have had a look at quite a lot of tools in our implicit modeling toolbox. Now, I don't expect anyone to remember all of them. Just the good thing is knowing that they exist, where they exist, and maybe a little idea of what they do. So with all of these tools, you can do almost everything with your wireframe. You can kind of trim it to the exact size you want. We can add additional points in places that we have extra data. We can change the resolution of our wireframe. And like I said, this applies across all three different types of wireframes. So our categorical, our vein, and our contact surface. So there we go, just patched up that hole just using an additional sample point. So unfortunately, there are more tools that we can get into, especially to do with the dynamic modeling itself. Unfortunately, we just don't have time at the moment, but there will be more webinars to kind of tune in. We can go through all the other stuff that we have here. So say our dynamic modeling properties window. So this allows us a little bit more in terms of, how we want our shapes to generate. We can also do stuff like change our proto model, cell block sizes. And then we can also get into things like how do we add a block model into our task? How do we add a macro into our task? So hopefully this will all come in the new year. There'll be another series of Studio Geo webinars. So thank you very much, everyone, for your time. But my contact details are here. Once again, if there's anything I covered there that you're unsure about, please just reach out. More than happy to have a little sit down and a talk about it.